Both prediabetes and type 2 diabetes is caused by insulin resistance, which is now accepted to be closely associated with the accumulation of fat within our muscle cells. This fat toxicity inside our muscles is a major factor in the cause of insulin resistance in type 2 diabetes, as it interferes with the action of insulin. I've explored how fat makes our muscles insulin resistant, how that fat can come from the fat we eat or the fat we wear, and how all fats are not the same. It's the type of fat found predominantly in animal fats relative to plant fats that appears to be especially deleterious with respect to fat-induced insulin insensitivity. But this insulin resistance in our muscles starts years before diabetes is diagnosed. This is a graph of fasting blood sugars in the 13 years prior to the onset of diabetes. Insulin resistance starts over a decade before diabetes is actually diagnosed, as blood sugar levels slowly start creeping up. And then, all of a sudden, the pancreas conks out and blood sugars skyrocket. What could underlie this relatively rapid failure of insulin secretion? At first, the pancreas pumps out more and more insulin, trying to overcome the fat-induced insulin resistance in our muscles, and high insulin levels can lead to the accumulation of fat in our liver, called fatty liver disease. Before diagnosis of type 2 diabetes, there's a long, silent scream from the liver. As fat builds up in our liver, it becomes resistant to insulin too. Normally, the liver is constantly producing blood sugar to keep our brain alive between meals. As soon as we eat breakfast, though, the insulin released to deal with the meal normally turns off liver glucose production, which makes sense, since we don't need it anymore. But filled with fat, the liver becomes insulin-resistant like our muscles, and so doesn't respond to the breakfast signal, and so keeps pumping out blood sugar all day long on top of whatever we eat. So the pancreas pumps out even more insulin to deal with the high sugars, and our liver gets fatter and fatter. That's one of the two twin vicious cycles of diabetes. Fatty muscles, in the context of too many calories, leads to a fatty liver, which leads to an even fattier liver. This is all still before we have diabetes, but then the next vicious cycle starts. Now, fatty liver can be deadly, so the liver starts trying to offload the fat by dumping it back into the bloodstream in the form of something called VLDL, and that starts building up in the cells of the pancreas that produce insulin in the first place. So now we know how diabetes develops. Fatty muscles leads to a fatty liver, which leads to a fatty pancreas. It is now clear that type 2 diabetes is a condition of excess fat inside our organs. The only thing that was keeping us from diabetes, from unchecked skyrocketing blood sugars, is that pancreas was working overtime, pumping out extra insulin to overcome insulin resistance. But as the so-called islet or beta cells in the pancreas are killed off by the fat buildup, insulin production starts to fail, and we're left with the worst of both worlds, insulin resistance combined with a failing pancreas. Unable to then overcome the resistance, blood sugar levels go up, and we have type 2 diabetes. This has implications for cancer as well. Obesity leads to insulin resistance, and our blood sugars start to go up, so our pancreas starts pumping out more insulin to try to force more sugar into our muscles, and eventually the fat spills over into the pancreas as well, killing off the insulin-producing cells, and we've got diabetes, in which case we may have to start injecting insulin at high levels to overcome the insulin resistance, and these high insulin levels promote cancer. That's one of the reasons we think obese women get more breast cancer. It all traces back to fat getting into our muscle cells, starting insulin resistance, fat from our stomach, or fat going into our stomach. So now it should make sense why the American Diabetes Association also recommends reduced intake of dietary fat as a strategy for reducing the risk of developing diabetes.